On to India's first animated live tuition. I welcome all of you to 90 plus my tuition app family. So guys, please do revise all the concepts which we learned in the previous session. So we just had the basic introduction of the concept of refraction, right? So let's get into the concept of refraction a little more deeper. So I want you guys to pay some special attention today. If you don't know this concept of refraction, the core part of it will be very tough for you. If you don't know the terms, you'll be struggling with the concepts. So today I'll be discussing some basic terms related to the refraction. So if you don't know these particular terms related to refraction, you'll be very confused with the topics coming up. You'll be very confused with the numericals which we solve. So before we proceed with the application part of refraction, before we check out the lenses, the image formation of lenses and all, you guys should know what is refraction, what is refractive index. Pardon guys, a little bit, I'm not feeling well, I hope you understand. So I'll not be putting some extra energy today, but who will be doing it today? Who will be putting extra energy today if I am not active over here? Who will give me some positive energy? Who will spread positivity to me? Only 1 or 2, 3, 4, 5, 6. How many of you is like smiling? Yes sir. How many of you will spread positivity today? So if your tutor is physically tired, what you will do? You guys will be like, yeah sir, it's okay. We'll give some extra energy from our side. Fair enough. You can go ahead. Isn't it? Because I don't want that to reflect in my session. Got it? I don't want that, okay, negative energy. No, positive energy. Let's get energetic for a brand new session. What you have to do? Please do revise. Some of you are sharing, support teachers are there to give extra energy. Today, Jayasudha ma'am is assisting you guys as a support tutor. Yes. What is that to do with the dinosaur, guys? This dinosaur is supposed to walk like this, so that when the dinosaur is here, no, you guys won't be looking at me, you guys will be concentrated on the dinosaur. So hopefully this is just an animation, right? So it won't eat me, I guess. Hi dinosaur, hi, how are you? Please do open your mouth. No. So over here you will be like, yeah, let's focus on the dinosaur. That's why I kept it over here. But should I keep it for the whole session? It will be tough, right? So you guys will be like deviated to the concept of dinosaur apart from refraction. Anyways, you don't want to discuss, it's not some biology or some evolution classes, right? So let the dinosaur be there itself. So let's keep it as a fun element in the beginning. When I move ahead, I will be taking it away. I'll be saying, dinosaur, please take rest. Let me go ahead with the concepts. So guys, do you remember the concept of deviation of light when we are considering an incident ray of light, some refracted ray of light, emergent ray and all? Do you remember the angle of incidence, angle of refraction and angle of emergence, these three things? Guys, do you remember? Nashwa, please don't support your jaw, support your head. Even I feel like to do like this, but you guys should give me some positive energy. And Nashwa is like, yeah sir, I'm dead. Not at all. You guys are the most energetic students over here, isn't it? Fine. So let's go ahead with the core concepts of refraction. Yes. So before we go, Achal has some query to ask. Hi Achal. Achal Krishnan. Why your hand is raised?
Yes, sir. No, sir, by accident.
Okay. So by mistake, emerald is okay. Light, when it hits the surface that divides the medium, for sure. The bending of light, bending of light with respect to refraction, we have learned about it, right? So let's check out the core concepts. So till now, what have we learned? So in the examples we have checked out, we have seen the different mediums involved. Air and water. What happens to the path of the light? It will undergo deviation. Where does the deviation of the ray take place? At the surface of separation. Fine. So, do you want to see the two different mediums which we consider? Is there any new students? No, right? Fine. So Kiran sir, can you please show me the first animation again for my new students who just joined today? You even have not seen the animation which we have checked out in the previous session, right? So let's check it out, guys. Don't worry. So everyone keep having a sip of water. We have considered a tumbler, a glass tumbler or a beaker. You can consider it as a glass tumbler, right? Fine. So let me fill it with some amount of water and I'll place a pencil in it. So over here, can you see a little bit bending is there, right? Over here, a little bit bending is there. So what happens? What is the reason for it? It's cause of reflection of light, right? Light is reflecting, so over here the pencil is broken. So actually it's cause of refraction, right? So actually the light ray is bent, the pencil is not broken. Even though we all are emotionally broken, the pencil is not broken, I guess. Everyone is thinking, yes sir, I can feel you. So guys, over here, the pencil is straight enough, strong enough, like you guys, but it appears to be broken. Deep inside, everyone is strong enough, physically, emotionally, as a whole. So, what is the reason for it? When we have considered two mediums, do you remember, guys? Oh God. Oh God. Are we in the eraser? Fine. So, just a second, guys. Oh God. Fine. So, when we consider two medium 1 and medium 2. So, medium 1, hi brother, medium 2. So hi brother and hi sister. So when there is a particular incident ray coming to this particular medium 1, will it undergo deviation? Will it undergo refraction or something? Will undergo, right? Will undergo deviation. What do you think? What do you think, guys? Do you remember the figure which we have checked out? Angle of emergence, angle of refraction, angle of incidence. Fine. So everyone do remembers it? Yes, Kiran sir, can you please remove the animation? Fine. So over here, what are we doing? Initially, we are considering an incident ray passing through the medium 1 and gets into the medium 2. But where can we see the deflection? At the point of separation between medium 1 and medium 2. So in this case, at this particular point of separation, we can see a particular deflection over here. Fine. So initially, we are considering medium 1, that is air, and next we are considering the medium 2, that is glass. So basically, when a ray of light passes from a rarer medium to denser medium, what happens? What happens? The refracted ray will bend towards the normal. When the ray of light passes from a denser medium to rarer medium, what happens? The refracted ray will bend away from normal. So everyone is like, sir, please don't teach us rarer medium, denser medium and all. First, let's discuss what is this rarer medium and denser medium. Isn't it? Are you confused? Node ahead. Do you want to learn about rarer and denser mediums? Yes. So first we'll check that so that you will have a better clarity of the concepts. First let's check out what is a rarer medium and a denser medium. So a medium in which light travels faster is called an optically rarer medium. Optics means, you know, right? Phenomenon of passing or the transport of light rays. So light rays, when they travel, they take informations. Do you remember? Do you guys know about the optical fiber? Optical fibers. Do you guys have internet connections over there, right? Wi-Fi and all. So what do they use? Which type of fiber they will use? They will use optical fibers. So the information is passed through those optical fibers using the light. Light is passed actually through it. So a medium in which light travels slower is called an optically denser medium. So that is the difference between rarer medium and denser medium. Please do note it down quick. If there is a medium where light can easily travel through it faster, which means optically rarer medium. So you can say the number of photons present in it is very less in rarer mediums. Medium in which light travels slower is called an optical. Denser medium, more particles, densely packed. Chance of moving the light through it will be tougher, so light will be traveling slower through it, much slower. So for rarer medium, what will happen? Do you guys know about the animal cheetah? Cheetah and tortoise. Okay, we'll consider a snail. That's way better, right? So cheetah and a snail. So guys, you won't forget. Otherwise, you guys will be confused in the case of refraction, even if you know what is denser and what is rarer. So with respect to light, when you consider a particular ray of light passing from rarer to denser or denser to rarer, the thing which should come to your mind is rarer is cheetah. Light rays travels faster through it. You know it, right? Cheetah is much faster compared to other animals. Anyways, cheetah is not so close to me. I am much faster than cheetah. Then the next one is snail. Snail goes very slow, right? Snail goes very slow. So like we can consider Shweta ma'am. Shweta ma'am, we have support tutor as Shweta ma'am as well. Shweta ma'am is also supporting over here. So she moves like a snail. Shweta ma'am is making faces. So don't make fun of me. Not fair. So guys, so slow and steady wins the race. Oh great! People are supporting Shweta ma'am. I should not have made fun of her. Fine. So cheetah and snail. Don't forget. Rarer medium, cheetah. Denser medium, snail. Don't forget. In denser medium, light travels slower. In rarer medium, light travels faster. Guys, why I'm taking so much of time in one single concept? Two different terms. Yeah. We started with the core concepts of refraction. Who was that, ma'am? You didn't miss anything, Sridhya. We have just started with the core concepts of refraction. I'm just explaining the terms which we are going to discuss. What is rarer, what is denser. In the case of denser medium, remember, the matter, the photons, the particles present in it will be very densely packed. So it will be tough for light rays to pass through it. So light travels slower. Rarer medium means rare number of particles, less number of particles in it, less number of matter in it. Because you guys know, light doesn't need a medium to travel, isn't it? Do you guys know that? Are you guys aware of it? Even in vacuum, light will be like, bro, I'll pass over there. Doesn't matter for me. So, in a medium where particles are loosely packed or less, that is a rare medium where light can travel fast. Denser medium, light travels slower. I hope the concept is clear for you. So, with respect to rarer medium and denser medium, when we are considering medium 1 and medium 2, suppose we are considering medium 1 and medium 2. Medium 1 and this is medium 2. So over here we are considering the medium 1 as the rarer medium and medium 2 as the denser medium. So over here you can see there is an arrow mark over here, right? Why is this arrow mark shown over here? It means that when there is an incident ray incidentting to the medium 2, it undergoes deviation. How it undergoes deviation? The light ray bent towards the normal. Can you see the arrow marked over here, guys? Nobody had like a puppet? So yes, we can see. So the light ray bent towards normal. Why? Why is it like that? What is the reason for it? Because in the case of denser medium, light travels slower. So light will be like, bro, I can't deviate much. I can't deflect much. So I'll be deviating a little bit. I'll stay close to the normal. I can't put much efforts. But rarer medium, light rays will be like, yeah, I'll take whatever deviation you want. My wish. So in this case, you can see that the light rays bend towards normal. If it was the other way, what will happen? when the light ray incidents from denser medium to rarer medium, what happens? Any wild guesses? So everyone is like, yeah. If in this case, if the ray of light, if the refracted ray bends towards the normal, in the case of vice versa, it'll be away from the normal, right, guys? Clear? When the light rays moves from denser medium to rarer medium, what happens? The refracted ray will bend away from the normal. Yes. Over here, fast is slow. Very good. Some of you have shared. So in the case of rarer medium, light rays will travel faster. In this denser medium, slower. In the case of slower, what will happen? Light rays will have a tendency to bend towards normal. And in the case of rarer medium, light rays will travel faster, so it will bend away from the normal. So over here, rarer medium and denser medium, the two different things. That is, in case of rarer medium, light rays will travel faster. Who wants to explain R and M again? Who was that?
Sridhar.
Sridhar, got it, Sridhar? Give me a thumbs up if you got it. What is a rarer medium? What is a denser medium? Please do raise your hands. Where is Sridhar? I want her to raise her hands. Sridhar, if you have a doubt, when you have shared it in the chat box, keep your hand raised. No, I can support you. Don't worry. Where are you? Where is Sridhar? Raise your hands. Fine. Sridhar, understood what is rarer medium and denser medium? I know you joined late, but tell me, like, in the case of rarer medium, what happens?
The light travels fast.
Faster, right? So, in that particular medium, light has some, what we say, free air to pass through it, right? Light can bend easily because the particles inside it is not densely packed. Understood? In the case of rare. But in the case of denser medium, the particles inside it is densely packed, so the light rays can't move easily. So light travels slower in it. Understood? And in the case of refraction, what happens? In the case of rarer medium, light rays can bend easily because light travels faster in it. So it'll have more deviation. So light rays will be bending away from the normal. But in the case of denser medium, light rays can't bend easily, so it'll be bending towards the normal. Got it, Sridhar? Got the concept?
Away from the normal towards normal. Yes, sir.
Away from the normal in the case of rarer medium. Why is that? Are you asking why does it bend away from the normal, right?
Yeah.
Because it can deviate much faster. Light can travel much faster. So more space is there. Light is free to move over there. Got it? Since light rays doesn't require a medium where it gets some space, free air, vacuum, it'll have a tendency to pass through it.
So why is it a problem to get into that normal?
Why is it?
Like, if it is free only, it can go anywhere, right? So it can
Got it.
go there, we can.
Got it. But in the case of, for example, when you consider a ray of light that is incidenting towards normal, imagine, Sridhar, focus over here. When there is an incident ray passing through the normal, I told you, it will not undergo much deviation, right? It will pass straight without refraction. Do you remember, Sridhar, in the last session we have discussed this? Do you remember? Yeah. So in the same way, over here, in this case, what happens? Light rays, in the case of rare medium, light rays will have more free space to travel, more free air. So it can easily deviate. So if you ask me why away from the normal, imagine if it's towards normal, will it have much deviation? It will not undergo much deviation, right? So for example, it goes through towards the normal itself or very close to the normal itself. So when we consider the incident ray, it won't be freely moving, right? When it has some free space or rarer medium to pass through it easily, what happens? It will deviate away from the norm. But it doesn't, when it doesn't have such property in the case of a denser medium, what happens? It it deviates closer to the normal because it doesn't have much deviation. The particles inside the denser medium is very densely packed. Light rays can't deviate much. So this normal is something which we consider as an imaginary line with respect to the angle of refraction of the light. Got the concept, Sridhya? Understood. So your doubt was why it is considered towards normal, away from the normal and all. Normal is an imaginary line which we consider so that we can understand. In the case of rarer medium, light deviates more. In the case of denser medium, light deviates less. So as to depict that, we are saying towards the normal, away from the normal and all. Got it? So you were asking why can't it bend towards normal? Towards normal means no much deviations, less deviation. Understood? Sridhya? Got it? Got it? Yes or no? Yeah. Yeah. Keep your camera in the landscape mode, you're on portrait mode. Yes. Fine. So guys, got the concept of rarer medium and denser medium? Real quick, let me know. Everyone got the concept? Type yes. I told you. Today I need some extra energy from your side. Give me a thumbs up or type yes in the chat box. Let me see that response. Some of you were asking what happens when the ray of light passes through the normal. The last session Shweta ma'am was sharing. Yes, for sure. If it's passing through the normal, obviously without any deflection or without any deviation, what will happen? The ray of light passes straight through it. Got it? Only in the ideal case, not in the case where the material which we are considering is densely packed, or if it's a denser medium, or if we don't have high refractive index. In such cases, there will be slight variations practically if you consider, but theoretically in an ideal case, what will happen? A ray of light which is incidenting through the normal will pass straight through it. Fine. So for a better clarity, Kiran sir will show us an animation number 4 so that we'll check out what will happen. Fourth one, yes. What will happen when we are considering the ray of light which is incidenting straight towards normal? Yes, let's check out. So guys, over here what are we doing? We are considering, so can you please put it behind? So over here what are we considering? We are considering a medium. So medium 2, let's consider the medium 2 as A, B, C, D. That is medium 2. So medium 1 is the free air. Medium 1 is the free air. This is medium 2. Yes, Kiran sir. So when we are considering an incident ray of light which is passing through the normal, straight through the normal, what will happen? The refracted ray will pass straight through it without any deviation or without much refraction happening over here. You can consider any medium, Mugdha Sunil. You can consider air, air is already there. You can consider water, glass, or anything. In all the cases, in ideal cases, okay? All the cases means medium can be anything, but the ray of light which is incidenting through the normal, which should have high refractive index. We'll check out what is refractive index. So the ray of light, when it passes through the normal, it will not undergo any particular deviation. It will pass straight through the medium, and it will come out. The emergent ray will be like this. Got it? Yes. Who was that? SA? Advait. Unmute Advait. Advait, you didn't understand what is a rarer medium and denser medium yet?
No sir, I just joined now, so.
Okay. So what you have to do is, Advait, please do watch our recording. Okay? This is the last warning you are getting. Because every single time you can't join late and ask me, sir, can you please explain it again? So the first 15 minutes I will be explaining till the end of the session. So no warnings for you. Got it? So the next time, join on time for the session. Clear?
Sir, I reached from school now.
Reach from school now. Fine. Then I understand. But no next time. Got it, Advait? This is the 10th time I am giving you an excuse. Got it? Yeah. So, yeah. The thing is, Advait, what you can do is, today's class is going on YouTube as live, but just for the time being, I'll help you. So listen carefully. So guys, imagine the same topic. We are studying the same topic. Those who were there from the beginning, they can ask. But if you guys are coming late and asking me, sir, can you take the session which we have covered till now half an hour? No. You're half an hour late, Advait. Anyways, so check out Advait. A medium in which, for example, if you're considering a particular medium, let be air, water, or anything. So in that particular medium, if the particles inside it is not densely packed, you know what is densely packed, right? Very closely packed. That is denser medium, where the light will travel slower. And a particular medium where the particles inside it are loosely packed. In that case, light can travel easily through it, right? Do you know that light doesn't need a medium to travel? Are you aware of it? Light doesn't need a medium to travel. So if there is some free space or vacuum, what will happen? Light will be like, yeah, I will go according to my wish. So when we consider rarer medium, the particles inside it are loosely packed. So in that case, light travels faster in it. Understood? There is no things which disturbs it. So light travels faster through a rarer medium and light travels slower through a denser medium. So that's the difference between rarer and denser. A medium in which light travels faster through it is called an optically rarer medium. A medium in which light travels slower through it is called an optically denser medium. And don't confuse with the cheetah, snail and all. Cheetah, I just mentioned to show it is faster. And snail, I just mentioned to show it is slower. Got it, Advait? So try to be on time, even though it's your school thing every day. Can't tolerate it. I hope you understand. Fine. Fine. Just a second. Diagram 1. Next slide after this. Yes, some of you need this diagram. So guys, draw two diagrams. So the first one, rarer to denser. So in this case, please don't forget to draw this arrow mark where the light ray or the refracted ray will bend towards normal in the case of a denser medium. And the next diagram, you have to draw it by yourself. What you will be doing? So on top you will be considering denser medium and over here you will be considering a rarer medium. A light ray will travel from denser to rarer. And in that case, light ray will bend away from the normal. So mark that arrow as. Got it? Don't forget to do it. So once you're done, show me the notebook and type down in the chat box. Then I'll come back. Kiran sir, can you please make me invisible in the meantime? Draw this diagram and draw one more diagram. That is the vice versa of this case. When the light ray incidents through the denser medium and passes through the rarer medium. Rare to denser is shown here. You have to draw denser to rarer. For Advait, who joined late, Advait, in the case of rarer to denser, what happens? The refracted ray will have a tendency to bend towards normal. Because light can't travel faster through it, it will be slower. No hurry, Priya. We'll finish the lens diagram by June 1st. Not possible, but we'll start for sure. Probably by next session we'll start somehow. Fine. So the next diagram will be denser to rarer. In that case, light rays, that is the refracted ray in rarer medium, will bend away from the normal. The deviation will be away from the normal. Please draw it, get it ready and show me and type done once you're done. Yes, Kiran sir. Once you're done, type done in the chat box. I want the responses from everyone, not just one or two. Everyone should respond. And those who have typed done, show me the diagram which I have drawn to the camera. Let me see real quick. So some of you is asking, sir, light deviates more in a denser medium. Am I right? No, you are wrong. Light deviates less in a denser medium, more in a rarer medium. Who was that? Suraj Sudesh, got it? So unmute Suraj Sudesh. Suraj, can please let me know what did you understand regarding rarer and denser mediums?
So rare medium is which is a place. So I have a doubt.
Yeah.
So if the medium goes to denser medium, does that mean it moves farther away from the normal?
It'll pass towards normal, it'll bend towards normal. The case of a denser medium. Yes. Because the case of denser medium, light travels slower, right? So slower means what? It doesn't have much chances for deviation. Got it? Since it doesn't have free space or free air through it, free air to pass through it. Understood, Suraj Sudesh? Got it?
Yes, sir.
Fine. So in the case of denser medium, light will have less deviation. In case of rarer medium, more deviation. Clear for everyone? Give me a thumbs up.
So,
Yes, Suraj.
sir, so when the medium in which speed of light is faster is a rare medium, right?
Yes, yes. When the speed of light is faster, that is rarer. When the speed of light is slower, that is dense. Fine.
Denser, yes, sir.
Yes. Got the concept, Suraj? Please be honest.
Yes, sir, I know that.
Yeah. Mohammed Shad, are you concentrating over here? I do remember you. Last time. Did you revise now? Mohammed Shad, unmute Mohammed Shad.
Yes, sir.
You have revised, right?
Yes.
Fine. Very good. Expect you have done it. I'm not asking you questions. Just for the time being. Guys, everyone done with the diagram, right? Can we go ahead? Fine. So rarer and denser mediums, we have checked it out. We have checked the medium 1 and medium 2. So guys, over here, so in the case of reflection, what we have checked out, when we see angle I and angle R, we'll consider it as angle of incidence and angle of reflection. The case of refraction is angle of incidence and angle of refraction. So at the point of separation, it will undergo deviation. So it will have a particular value of refraction. So that is marked as R. And when this ray of light comes out of this medium, when the ray of light comes out of this medium, what happens? It will have a particular deviation or it will have a particular angle of incidence. So with respect to the normal, we will be marking it. Got it? So in the case of refraction, the only thing you have to remember is, in ideal case, what will happen? What will be the difference with respect to angle of incidence, refraction, and emergence? We'll check it out. Yes, Sridhya, what's your doubt? Sridhya.
Sir, how should we draw the second case? Medium 1 and medium 2 and then medium.
Yes, if in this case, so in the first case, if the ray of light bends towards the normal in denser, how will it be in the case of rarer? Please do unmute Sridhya again. In the case of denser to rarer, in the case of rarer to denser, the refracted ray bends towards the normal. Towards the normal. Denser to rarer, what will happen? Sridhya.
It will be just opposite.
It will be opposite, right? Opposite means what? The refracted ray
Normal.
away or towards?
Away from the normal.
Away from the normal. So just the vice versa, we have to draw it. So two medium will be considering. So in the top part we'll be considering the denser medium. Then we'll be considering the rarer medium. Oh God. Got it? So what happens? Yeah, when we are considering an incident ray, yeah, with respect to the normal, imagine I'm drawing it with respect to the normal. So what will happen, Sridhya? The refracted ray will bend away from the normal. So in the previous case it was towards the normal, but in this case it goes away from the normal. This is the refracted ray from denser to rarer. Why? In the case of rarer, light travels faster, so it can deviate more space in it. The particles in it are loosely packed. Got it, Sridhya?
Yeah, so what's the real life example for this?
Real life example we can consider air and water. Water and air. Which medium will be densely packed, which will be rarely packed, which will be denser, which will be rarer. Sridhya, think about the substance in the medium which we are considering. Water and air. Which one will be rarer and denser? Sridhya, are you there?
A rare medium would be
Rarer medium will be air, right? Air will have more free space. Water will be denser. So over here denser to rarer, from water to air, or air to water, the other vice versa. Got it? So for example, it'll be tough for you to consider water on top and air in the bottom part. It'll be tough, right? So for such cases, we can consider glass and water, glass and air. Fair enough. Got it? So with respect to rarer and denser, we'll be considering two mediums, denser and rarer. So real life example, we can consider air and water, whereas air will be rarer and water will be denser. Got it? Fine. So Aris Abbas, can you please unmute yourself?
Also, in which is the denser travels faster,
Come again?
Which travels
which
In which light travels faster? In rarer, light travels faster.
in there, right?
Yeah, in rarer. Got it? Fine. So I hope you guys have written it. This is important. Note it down. Light travels faster in rarer, slower in denser. Denser, slower, rarer, faster. Rarer cheetah, denser snail. Who is that? SA?
Same. Aris.
Iris, fine. Iris, is your doubt cleared? I can see a doubt in chat box. Cleared, right? Who is that? SM? Cleared. Yes, Marin ma'am. Is it clear?
Yeah.
Yeah. Fine. Any doubts? No, right? Let's go ahead. So rarer and denser media, I hope you got an idea. You got what means rarer and denser medium. So when we discuss more concepts related to it, we'll have better clarity. So guys, please check out this table of refractive index and speed of light. Don't worry about refractive index. We'll check out. So speed of light means what? You know, right? What is it? The speed which light travels through a particular medium. So in air, the speed of light is 3 into 10 raised to 8. Do you guys remember? In physics, in motion chapter 9 grade, you guys might have used the speed of light 3 into 10 raised to 8 many times, right? Or in gravitation. Do you guys remember 3 into 10 raised to 8? How many of you remember? Wave your hands to the camera. In grade 9, you might have used it. Speed of light is 3 into 10 raised to 8. There was a constant value, there was an ideal general value. Fine. Then, with respect to water, this is 2.3 into 10 raised to 8. Perspex, glass and diamond. Guys, the only thing which I have to say is, you guys should not memorize these values, not required. So what you have to do for numerical problems? Who was that? Fatima Jumane is like, yeah, thank you sir. Anyways, I didn't plan to remember, but since you mentioned it, I'll forget it. So guys, what you are supposed to do is, you guys should know the comparison. No. Harry Prey is asking, should we learn all the values given in the table? No, you don't have to learn all the values given in the table. But what is the thing which you have to remember from this table? Do you think diamond is a denser one, more denser one, or air is the most denser one? Which one? Diamond or air? Which is the most denser material which we can consider? Air or diamond? Everyone type your answers. Type your answers. Type your answers. Diamond, right? Diamond. So, over here you can see that compared to the speed of light in air, in the case of diamond, is it slower? Is it slower? 1.2 into 10 raised to 8. But in the case of air, 3 into 10 raised to 8. Understood the difference? As I told you, in denser medium, light travels slower. In rarer medium, light travels faster. So this comparison you should know. Air, water, perspex, glass, diamond. So everyone is confused. Some of you are asking, sir, what is this perspex? So you don't have to think about it. What you have to understand, in the case of solid materials like diamond, particles will be densely packed, so the speed of light in it will be less. Case of air, the speed of light will be greater compared to this water, perspex, glass and diamond. Got it? It's a particular material. So if you ask me why did we consider perspex? Perspex stands between water and glass. That is what we say. Not a type of glass, what we say a mixed kind of thing. Mixed kind of thing. It's not rock solid. It's not like so liquidistic like water. That is perspex. Got it? So it's particular material that is like what we say. We can say neutral form of water and solid. Okay. Now, when we are considering the refractive indexes, can you see a significant difference with respect to air and diamond? In the case of air, the refractive index value is very less, just 1. But in the case of diamond, it's 2.42. So you learn in detail about refractive index, but as of now, what you have to remember? In the case of rarer mediums or in the case of air, refractive index will be very less and goes on more denser like liquid or water and perspex, glass, diamond. When it goes more densely packed or solid material, the refractive index increases, whereas the speed of light decreases. So these two tables, that is refractive index and speed of light, are contradicting. In the case of air, speed of light is greater, but refractive index is the smallest value. But in the case of diamond, speed of light is lower, but the value of refractive index is greater, 2.4. Understood that's different? So regarding refractive index, we will learn about it so that we will have a better clarity of it. So that is the only thing which you have to remember with respect to the table given over here. Don't try to memorize the values. Such values required for your exams or numericals which we are doing, you will be getting the values in the question itself. Got it? So some of you are asking, sir, what is the value of refractive index in vacuum? It will be the same as of air. Got it? Because in the case of air doesn't need a medium to travel. So it will be the same in air and vacuum as well. Got it, everyone? Speed of light in vacuum will be the same, 3 into 10 raised to 8. Who was that?
Rehan. Indian.
Indian, is it clear? Nod your head or give me a thumbs up. Where are you? Fine. Got it, right? Fine. So over here, that is the only thing you have to remember, this comparison. In the case of solid, speed of light slower, air faster, air refractive index smaller value, diamond greater value. That is the only thing which you have to memorize. Yes. So Leora comes up with some new theory. So the speed of light is inversely proportional to the refractive index. Yes, for your reference you can remember like that. Theoretically we don't say it like that, but from the table, from the proofs, our scientist Leora D'Souza comes up with some complex ideas. Sir, speed of light is inversely proportional to the refractive index. You can say like that, just for your reference, so that you can memorize it, right? Fine. Done, everyone? So you don't have to draw this draw this table. It'll be given there in your textbook. You don't have to write it down. No, not required. Those who have already started it, you can take a screenshot, because I won't be giving you time to write it down. Those who want to write it, it's not required. You just have to memorize the comparison. It is given there in your textbook just for your reference. Can I go ahead? So let's learn what is refractive index. Let's consider what is refractive index. Everyone makes their eyes like this, sir. Background is disturbing. So actually, I just meant to say when the ray of light is incidentting, it will undergo some deviation. So all the light rays are undergoing deviation, right? Jesuda ma'am is also like, sir, tough background, not able to focus. So the ratio of, Kiran sir, can you please take down my name tag? The ratio of the speed of light in vacuum to its speed in a specific medium is termed as refractive index. So guys, instead of vacuum, you can consider air as well. Instead of vacuum, you can consider air as well. Means free space. Vacuum or air, in both the cases, light will be like, bro, I don't care, I don't need a medium. So the ratio of speed of light in vacuum to its speed in a specific medium. So for example, let's consider water and air, or let's consider glass and air. So when we consider glass, water, or any particular medium, any solid substance, let's consider diamond and air, diamond and vacuum. So this ratio of speed of light in vacuum to its speed in its specific medium means any particular medium which we are considering. Glass, water, diamond, perspex. You guys were so curious. So what is this perspex? Got it? Fine. So that ratio of it is termed as refractive index. So when we consider the ratio of the speed of light in vacuum to its speed in a specific medium, we will be applying a complex concept, that is Snell's law. So it will not be asked for your exams, but just for your reference, please do remember. When we calculate the ratio of speed of light in vacuum to its specific medium, we will be considering a constant of Snell's law, that is sin I by sin R. So you'll be thinking, what is this sin I, sin R and all? That's the angle which we are considering. So when we are considering the deviation of the ray of light, we'll consider its angle. So there will be a constant value. So that particular sin I by sin R, that constant value will give the ratio of speed of light in vacuum to its speed in a specific medium. That is an advanced concept. So at your level, you don't have to learn about it. Just keep it in your mind. So if someone asks, there is some connection? Yes. Yes, it isn't there for boards. Yes. No, it isn't there. Some of you are asking, sir, Snell's law isn't there. No, it's not there. I know it. So just for your reference, I gave it. Don't get confused. Oh, sin I or sin R, are we going to learn trigonometry in physics? No. So you'll apply it anywhere. So the speed of light in a medium depends on the properties of the medium. So you know it, because in the table we have seen, in air the speed of light was greater, but in diamond it was slower. Properties of the medium in the sense, in the case of diamond, the particles inside it are very closely packed. Graphite structure in chemistry, if you have learned about diamond, do you guys remember? Very closely packed graphite like structure. What we say? Hexagonal pieces. Anyways, don't get complex with it. Just understand that in the case of diamond, very closely packed particles. So in that particular medium, speed of light will be less. And this refractive index is also termed as the measure of the bending of a ray of light when it is passing from one medium into another. That is also termed as refractive index. Why? Because always when we calculate refractive index, what we'll be doing? We'll be considering speed of light in vacuum to its speed in a specific medium. So always when we are considering two mediums, air will be there, right? Air and water, air and glass, air and diamond. So always air will be like, bro, I'm here. And if you are considering denser to rarer, imagine what we'll be taking. We'll be taking glass and air, or diamond and air. For denser to rarer or rarer to denser, as a rarer medium, we'll be always considering air. Don't forget it. That is why when we calculate refractive index, this speed of light in vacuum or speed of light in air is taken as a reference point. So it is taken as the base of it. Understood, everyone? Don't get confused. Why always air? Don't be like, why are we taking air always? Do we have some extra affection to air? No. That is the perfect rare medium which we can take in all the cases. We can't take Fatima Zahra as the rare medium. Fatima Zahra is very denser. So, we'll consider air in general. So, Fatima Zahra won't be supporting her head because you'll be joining my club. I want you to stay more energetic over there. Don't support your head. Fine. Are you not feeling well, Zara? Energetic, right? Fine. So it is also termed as refractive index, is also termed as the measuring of the bending of a ray of light when it is passing from one medium into another. Please don't forget. Okay, Devanand is asking, we have the whole chapter, don't worry, including Snell's law, not required, but just for your reference, I'll give it, don't worry. It's coming up, but just for your reference, I'll discuss, don't worry. So Devananda is like, sir, you told about Snell's law, but you are not taking it into reference in the case of refractive index. I'm coming to it. It's there, even if it's not that important, just for your reference, for your understanding, I'll consider. I'll let you know how the speed of light in a particular medium with respect to the other, we're considering the ratio. I'll give you a better clarity. First, please do note it down. This is the base of it. When you got the base, no, we can get into the core part of it. Refractive index is not yet done. So I'll give you some examples. I'll give you some comparison of different speed of light so that you will get better clarity of it. Yes, with respect to the Cbse boards, Snell's law will not be there in detail, not required, but for example, if it comes for 1 mark and all, in last year board exams also, there were questions for 1 mark part and all from deleted portions as well, right? So in that case, we'll have some basic, just 1 mark question or something. Don't get confused with it, we'll discuss it. Even though it's not that mandatory, just for your reference, I'll go ahead. And if it's there in your school, I can't help it, so you have to learn it. So how I'll be helping you? I'll be telling you this how Snell's law comes over here with respect to the refractive index. So but don't say sir told it's not that important, but in my school tests I got it. I can assure you in board exams you won't be coming, but in your school if your teacher wants you to learn or know about it, you have to learn it for sure, or you have to keep an eye on it. Even though it's not that important, we'll check out. Guys, everyone written it? Can I go ahead? Quick. Fun. So, when we are considering two mediums, medium 1 and medium 2, consider we are taking speed of light in medium 1 as v1 and speed of light in medium 2 as v2. Everyone draw the two medium 1 and medium 2. And mark in your notebook, speed of light in medium 1 is termed as v1 and speed of light in medium 2 as v2. Now let's go along with me. The particles packed in it, particles present in it. Who was that? Marin ma'am. So what properties does the medium depend on? It will depend on the particles inside it. It will depend on how densely packed the particles are. It depends on the material particles inside it. For example, it'll have photons, it'll have other type of neutrons, it'll have some different definite matter in it. So all these things will be dependent on it. Who is that?
Rayhan.
Rayhan, clear? Where is Rayhan? Down there. New message is coming on.
Please go to the previous slide.
Yeah, who wants the previous slide? Guys, I gave you 10-15 minutes just for this. You guys didn't note it down yet. Mohammad Muzab, where were you? Raise your hand. Kiran sir. Mohammad Muzab, where are you? Why you didn't note it down when I was explaining Mohammad Muzab? I told you not to write when I'm explaining, but I gave you time to write as well, right? Why you didn't note it down, Muzab?
Actually, I didn't listen. Actually, I didn't like hear you what you said. You have to note it down. That's why.
Okay, now it's clear, right? Now you don't have any doubt regarding the concept, right?
No.
Fine. Are you done with it?
Yeah, the last one.
Done now? Quick. Once you're done, give me a thumbs up. Anaka has given some extra options, I guess. Anaka, you have given some extra options. You want to control our camera. Over here in Zoom, I can see a message. Anaka Srijit would like to control your camera. Anaka, please don't remove me from the meeting. Fine. Muzab, can I go ahead? Show me a thumbs up if you're done. Everyone is waiting. Fine. So speed of light in medium 1, V1, speed of light in medium 2, V2. I hope you have noted it down. Now, let's mark N12 as the refractive index of medium 1 with respect to medium 2. So before we write, think about refractive index. What is refractive index? Ratio of speed of light in vacuum to its speed in a specific medium. Got it? So, when you are writing refractive index of medium 1 with respect to, or refractive index of medium 2 with respect to 1. 2 with respect to 1, we will mark it as N21. 1 with respect to 2, we will mark it as N12. So, this denotation, please don't forget. You might have noted these denotations in mathematics as well, right? When you draw matrices N12, N21. Have you guys done it in maths? Such denotations? Not yet. Yes, Jaswin is like, yes sir, we have done such things in mathematics as well. Yes, who was that? SR. Fancy doubts coming up. So will there be numericals for refraction? For sure.
It's Rihan.
Rihan P. Shahjahan. For sure, Rihan. Numericals is coming up. So related to refractive index and all, very less, but with respect to lenses, more numericals will be there. We'll discuss it. So here we have considered the refractive index of medium 1 with respect to 2, refractive index of medium 2 with respect to 1. That is N12 and N21 respectively. So N21 is equal to speed of light in medium 1 divided by speed of light in medium 2. Speed of light in medium 1 divided by speed of light in medium 2. That is, speed of light in medium 1 is V1, we know it. Speed of light in medium 2 is V2. So V1 by V2 is N21. Don't forget it. So guys, this is not something which you have to by heart. These are some general denotations we are taking. So speed of light in medium 1 divided by speed of light in medium 2 is termed as V1 by V2. You will get to know why I am considering all these terms. You'll understand. Now you'll be like, so what's happening? Why we are taking all these denotations? I'll let you know. Quick. Fun. Everyone done, right? The previous one? I done with it? Done, right? Quick. Not done. Quick. Some of you are saying, sir, not done yet. Refractive index of medium 1 with respect to medium 2. Refractive index of medium 2 with respect to medium 1. N21 is equal to V1 by V2. Speed of light in medium 1 is V1. Speed of light in medium 2 is V2. So over here you can see medium 1 and medium 2 is marked. This is the surface of separation. This is the surface of separation. This is the surface of separation. Once you are done writing down, give me a thumbs up. Yeah, I know. Some of you are saying, sir, so many with respect to. I'm getting confused. Don't worry. Once we discuss it completely, you'll get a clarity. You have to wait. You are supposed to wait. So guys, that is why I say, if you're writing it real slow, what happens? The flow of it goes away. So we'll take it ahead real quick. Yes, you are supposed to write n12 also. If n21 is speed of light in medium 1 divided by speed of light in medium 2, that is v1 by v2, what will be n12? What will be the n12? What will be n12? N12 will be, so you guys wrote n21, right? So if n21 is the speed of light in medium 1 with respect to speed of light in medium 2, speed of light in medium 2 with respect to medium 1, in the case of n12 will be the opposite, right? Refractive index of medium 1 with respect to medium 2, or speed of light in medium 1 with respect to medium 2. So this is the refractive index, and here it is speed of light. Don't get confused with it, because it is inversely proportional, right? So we are considering n12 is equal to speed of light in medium 2 with respect to speed, oh god. So here medium 1 divided by medium 2. In the case of n21, what will happen? Medium 2 divided by medium 1. So n12, oh god, speed of light in medium 1 divided by speed of light, medium 1 or medium 2? Medium 2, right? Medium 2 with respect to speed of light in medium 1. Guys, you guys will be confused. Why it is medium 2 and 1? Because, don't say sir, in this it was 1 and 2, so the other case will be 2 and 1, right? Because you guys know that refractive index and speed of light is inversely connected, right? Inversely related. So in n21, it was a refractive index of medium 2 with respect to 1. But in the case of n12, it is refractive index is with respect to medium 1 with respect to medium 2. Understood? So when we consider speed of light, it will be vice versa, right? Speed of light in medium 2 with respect to medium 1, isn't it? So in with respect to refractive index, it is 1 and 2. With respect to speed of light, it is 2 and 1. Understood the difference? Guys, do you remember this table? So Leora gave some theoretical connection for you guys. Speed of light and refractive index is inversely proportional. When the speed of light increases, the refractive index reduces. When the speed of light decreases, refractive index increases. Do you guys remember it? Do you guys remember it? You do, right? So based on that, you are writing n21 and n12. So n12 will be speed of light in medium 2 with respect to speed of light in medium 1. So with respect to the denotation, we can write it as v2 divided by v1. Guys, do you remember v1 and v2? Speed of light in medium 2 divided by speed of light in medium 1. v2 divided by v1. Now, so till now you guys were very confused. Sir, n1, 2, n2, 1, speed of light in medium 1, 2 and all. So in general, let's consider two cases of, let's consider the case of air and glass. Two mediums we are considering. So speed of light in air with respect to speed of light in glass. That is 3 into 10 raised to 8 meter per second divided by 2 into 10 raised to 8 meter per second. So here we can consider it as the speed of light in glass with respect to the air. That will be the refractive index, right? So this is the refractive index of glass with respect to air. Always when we are calculating refractive index, what will be there? Vacuum or air will be there. Don't forget. Always with respect to air or vacuum, we will be calculating refractive index. So when we're calculating the speed of light in air with respect to glass, we'll get the refractive index of it. So 3 into 10 raised to 8 divided by 2 into 10 raised to 8. If we do it, we'll get the value as 1.5. You'll get the value as 1.5. That is the refractive index of refractive index of glass with respect to air. Why 1.5? 3 divided by 2. This 10 raised to 8 and 10 raised to 8 will get cancelled. So 3 divided by 2 is 1.5. You guys know it, basic division. So it is 1.5 is the refractive index of glass with respect to air. Got it, everyone? Yes, this particular comparison you should remember. Fatima Juman is asking, so should we memorize it? Yes. So Haya Fatima is asking, sir, what is N21 and N12? So what we did is, we have considered two mediums, medium 1 and medium 2. That is the general case. And this is an example. So that's why I told you, when we consider an example, we have a better clarity. To know the refractive index of glass, what we took the speed of light in air first. Then with respect to that, we have considered the speed of light in glass. So air by glass, when we are doing it, we will get the refractive index of glass. So you'll be thinking, glass should come in the numerator, right? No. To get the refractive index is the inverse of speed of light, right? So if we consider speed of light in glass in the numerator, will we get the refractive index properly? No, right? It will be upright. Oh God. So what will happen? We are supposed to take the speed of light in glass in the denominator and speed of light in air in the numerator. Since speed of light in air will be registered in your mind, right? 3 into 10 raised to 8. So this value you guys will not be aware of it. So you guys won't be memorizing it, right? So if such cases comes for exams, so for example, what is the refractive index of glass? So if there is a question like that, in bracket it will be given the speed of light in glass is 2 into 10 raised to 8 meter per second. And this value of speed of light in air, you guys will have it in your mind, right? Because you have used it in 9th grade already. So this particular value you have to memorize. This particular value I don't have to say you have to memorize. It will be there in your mind already because in 9th grade, in gravitation, motion, in a lot of chapters, you have used it. So you guys know it. So speed of light in air won't be given because you know it already. But the speed of light in glass or any other material which is asked in the question will be given over there with the question itself. So if you have a question, what is the refractive index of glass with respect to air? What will be doing? You will be considering the speed of light in air in the numerator. You will be considering the speed of light in glass in the denominator. Calculate, then you will get the value as 1.5. Got it? Sridhya, any doubts?
Sir, can you say like, what is N12 and what is N21?
That is general case of medium 1 and medium 2. So for example, here we are considering medium 1 and medium 2 as glass and air.
Yes, sir, but the value of V1, V2.
No, we don't have a value for it. This is a general case. Some random equation to know, to denote N12. For example, this N is the refractive index. So, for example, if you have to write the refractive index of glass with respect to air, you can denote it as NGA. Now you understood? So for G or the glass, we are considering it as medium 1 and air we are considering it as medium 2. Or NAG. Okay, with respect to N12, you are supposed to write as NAG. So with respect to N12, you can write as NAG because over here the medium 2 is air and medium 1 is gas. So this is the general case of it. Understood? If you are calculating it with respect to medium 2 and 1, if you are calculating it with medium 1 and 2, it will be NGA. So the general case of it is N21 and N12. Understood, Sridhya? Got it? Give me a thumbs up. Okay. So please do note this down as an example. Only if you know this down, you'll have a clarity of the concept. Or you guys will be very confused. Why N21, N12 and all? That's the general case of it. Understood? What happened, Jayasudha ma'am?
Nothing.
Yes, you have to memorize the
They
value.
asked the unit of refractive index.
Somebody is asking about the unit, sir.
No, there is no unit, right? Leora, is it clear? For refractive index, there is no particular unit required. That is Leora. Got it, Henry's? Got it? Not possible. So guys, done? Can I go ahead? I don't note it down, right? So we'll go ahead. So speed of light in, medium 1 and medium 2 we have considered. So with respect to that we have written n21. So the refractive index of n12 will be speed of light in medium 2 with respect to medium 1. So that is v2 by v1. You guys know it already. We have written it already. So no need to write it down. You guys have noted it already, I guess. Now, please do note it down. The refractive index of one medium with respect to another is called relative refractive index. One medium with respect to another. So, do you remember N12 and N21 we have considered 1 and 2. And the refractive index of a medium with respect to vacuum is called absolute refractive index. So, you guys will be thinking, refractive index is always considered with respect to vacuum, right? But if you are not considering vacuum, or if you are considering two different mediums, just the mediums, so that is relative refractive index. This absolute refractive index is also known as just the normal refractive index. It's the normal one. So this general refractive index, which we have already learned, is also termed as absolute refractive index. Why? It's the actual refractive index of a medium with respect to vacuum. That is how you should calculate refractive index. And imagine, we are not considering air. I told you to get a rare medium, the best fit is, the perfect one is air. Somehow, if you are considering water and diamond, we can take water as rarer, right? Because diamond is very densely packed compared to water. Guys, can we do that? But in that case, can we call it as the normal refractive index or the absolute refractive index? No, right? In that case, what will be calling it? We'll be calling it as relative refractive index. So that is refractive index of one medium with respect to another. Guys, is it clear? Is it clear? Fine. Note it down. So absolute refractive index is also known as the normal refractive index. Please don't forget. Speed of light in vacuum itself is considered as the speed of light in air. You guys know it already, I have shared it. Speed of light in air or vacuum, it is the same, 3 into 10 raised to 8. So speed of light in air or vacuum is considered as C. Speed of light in a medium is considered as V. Yes, Kiran sir. So absolute refractive index of the medium is speed of light in air with respect to speed of light in the medium. We learned it already, refractive index. So it is the same. Why are we taking it again? Just to discuss about relative refractive index. Got it? So denotation is C by V. Speed of light in air or vacuum is denoted as C, and speed of light in any particular medium is denoted as V. So absolute refractive index is termed as C by V. Please do note down the denotations real quick. Whose face seems confused? Any confused faces? Even if you didn't raise your hands, no, I'll be asking you. Because I want someone who is confused. Because some of your faces are very confident. Got it. Some of your faces are like a little bit confusion is there, but I'm so shy to ask. What will my friends think? Will it be a dumb question?
Nabiha.
Nabiha. Nabiha, right? Hi Nabiha. Yes, what? I can't hear you. First of all, you are on mute. Yeah, still I can't hear you. You are unmuted, but I can't hear you. Nabiha, you didn't fix it yet. I told you by the next session you have to fix. Try to unplug your headphones or earphones. Now you try to speak. Some of you are asking about exam time, guys. We can do it in 5 minutes, right? Easy 5 questions you will get. So maximum portions will cover. Why are we lagging it? Already I am taking a lot of time for one single concept. Why? Because I want it crystal clear for you all. Sit properly. Who was that? Frank George, right? It's George. Ivan, right? George Jiju. Straight to Marin ma'am. Straight in front of, yeah. Now that left.
Hello.
Hanok George. Sit properly. Since you understood refractive index, Hanok is like this. Hanok, sit properly in the session. Unmute Hanok. Hanok, right? Hanok or Hanok?
Hello, George.
Is it Hanok? How should I pronounce the name?
Yes, sir. Sir, it's
Hanok, right? Did you understand the concepts?
Yeah.
What is the difference between relative refractive index and absolute refractive index? Don't read what is written over there. Tell me what you have understood. Give me an example or something. In your own words, you can answer.
It's like one medium to another is called relative refractive index.
Okay, if we are considering two different mediums, we can term it as relative refractive index. But if we are considering the refractive index with respect to Hannah, join me. I'm helping you. With respect to vacuum or air, in that case, it is the actual refractive index or absolute refractive index or the general refractive index which we are considering. Got it, Hannah?
Yes, sir, it's Hanok.
Hanok, right?
Yeah.
Hanok. So, did you get it? Clear?
Yeah.
Fine. Everyone done, right? Yeah. So Linda is asking, sir, can you explain that diamond explanation again? Diamond example, if you are considering, for example, when we are learning relative refractive index, we'll be considering two mediums, right? Medium 1 and medium 2. So what we'll be doing, we'll be considering two mediums. So for example, water and diamond. So when we compare water and diamond, which one will be more denser? Diamond for sure. So water we can consider as the rarer one. So in that case, are we taking vacuum or air? No, right? So when we calculate the refractive index, in that case, we will be considering two mediums, medium 1 and medium 2, that is water and diamond. So in that case, the refractive index value which we are getting is the relative refractive index of it, not the absolute refractive index or the actual refractive index value. It's the relative refractive index value. When we are calculating the refractive index with respect to vacuum or air, we can call it as absolute refractive index. So Linda, is it clear? Got it? Fine. So speed of light in vacuum is c by v. So absolute refractive index is normally known as refractive index only. General case. Please do note it down just for your reference. Or you guys will listen to it and forget. Write this down. Absolute refractive index is normally known as refractive index, the general case. Those who got the concepts will keep some smiling faces to the camera. How many teeth you guys have? 28 or 30, 32? However, keep your 32 teeth or 28 teeth in front of the camera. Don't be like close to the camera. Don't eat the camera. Just keep it like this. Sir, I got the concept. How many of you got the concept? So those who got the concept will smile to the camera. I'm going to take a screenshot. Anaka, you didn't get the concept? Anaka is like, I didn't get it. Jerome, you didn't get the concept? Jerome Juice. Jerome Juice Foods, right? Julius. Yes. Jerome? Julius. Jerome, you didn't get the concept? I didn't see a smiling face. Unmute Jerome. Jerome, what happened? Broke up? Relationship issues? Broke up with your girlfriend? No, right? Fine. So why I can't see the smiling face over there?
Sir, I don't have a smiley face. I only have thumbs up.
Come again?
I only have a thumbs up in reactions.
Okay, you just share thumbs up. Fine, got it. Some of you are sharing emojis in the chat box. So guys, over here, This is the table which is already given there in your textbook, where the absolute refractive index of different materials is given. Got it? So, what are the medium which we are considering? What are the material medium? So, two material mediums which we are considering. So, what is the refractive index of it? So, that is shared. Got it? Refractive index of air, refractive index of ice, rock salt, all those things is given over here. Got it? So, ice with respect to air, or the absolute refractive index value of each of it is given over here. So, what you have to understand from this also is, can you see, guys? Guys, don't think why two comparisons. This particular part should come below it actually. So just for your reference, I made it two halves. Then I have just joined it together. Don't get confused. So initially, when we consider air, the refractive index value is very less. So as it goes more denser, Canada balsam, rock salt, carbon disulfide, dense flint glass, ruby, sapphire, diamond. So when it goes more complex, densely packed stones or solid materials, the refractive index increases. In the case of air, very less. So don't think, oh God, how will I memorize all these values? Not required. Not required. Just understand that in loosely packed materials or like air and all in rarer mediums, refractive index value very less. In densely packed strong materials or solids like diamond, sapphire, ruby and all, guys, you know, right? Precious stones, ruby, sapphire and all. Fine. I have 10 sapphire stones with me. So everyone is like, sir, stop boasting. We'll go ahead with the concept. So I hope you understood. You got it, right? Fine. So optical density, we'll learn about optical density in the next session so that we will have a better clarity. Before we proceed with the exam time, okay, Sridhya, unmute Sridhya. Is it still messed up or where you have a doubt?
Just need to revise everything.
That's it. Once you revise, still if you have a query, keep it written, ready over there to shoot in the next session. Got it? Don't say, sir, when I revised, I had doubts, now I don't remember. So, as to remember, write it down. In the next session, you can shoot in the beginning. Sir, don't start, I have some 10-15 doubts, then we can go ahead. Clear, Sridhya?
Yes,
Yeah, once you revise, write it down. Guys, you can click on the exam tab, submit your responses real quick. So optical density we will discuss in detail in the next session. Just for your reference, if you want, what you have to do is take a screenshot. Write it down and come so that we can save some time in the next session. Oh God, it's not going up. Optical density is a measure that shows how a medium influences the speed of light passing through it. How a medium influences speed of light. I told you, in rare medium speed of light will be faster, in denser medium speed of light will be slower. So that is the measure of it. How it becomes slower and faster. Because of what? That particular property is termed as optical density. As optical density of a medium increases, speed of light decreases. It is inversely related. When the optical density increases, speed of light decreases. So in detail we will discuss in the next session when I give you some examples and all. You will have better clarity. As of now, take a screenshot. Let's go ahead. Who typed demand and all? Honey, not demand. It's diamond. Demon or what? Demon, devils and demons. So some of you got 10 on 10. I guess questions were there, right, related to optical density. Since I have been discussing about optical density, everyone was like, sir, thanks for showing that slide. We had some questions. So for free, we got 10-15 marks. And sparing just for today, not every day.
Sir, someone is asking for the second last slide.
Second last slide. Who was that? Who wants the second last?
Sridhya.
Sridhya, which one? Optical density 1 or what? Unmute yourself. Or the table. Table is given. If you are asking about the table, it's given in your textbook. This one or the previous one?
The absolute refractive and index absence.
This was already there in the previous slide. Only this particular point is added. Absolute refractive index is normally known as refractive index. Got it? Yeah. Sridhar is like, sir, there was one question in the exam, so for that I asked so that I can answer easily. Is it? No, right? Fine. Everyone is like, even if it was helpful, I won't reveal. I'll do some drama. No, right? Sridhar didn't do that. I was just making fun of her. Guys, done everyone? 10 on 10? 8 on 10. I think I messed up. Who was that? SI? Sub-inspector or what? Indian, where did you mess it up? Which question you made a mistake? What do you think? Indian, can you please unmute yourself? You don't remember which question you messed up? You're not sure? Fine, we'll discuss it. So the first question was, oh god. So the first question was the refractive index of a medium with respect to vacuum is called as. You guys know it, right? It's called dash. Of a medium with respect to vacuum, it is absolute refractive index. It is absolute refractive index. Speed of light in vacuum itself is considered as the speed of light in air. Is it true or false? The statement, is it true or false? True, right? So speed of light in vacuum itself is considered as the speed of light in air. Absolute refractive index is normally known as refractive index as well. Sridhar is like, sir, I asked you, right? Absolute refractive index is also normally known as refractive index. So the statement is perfect. So it is true. Now, dash is a measure that shows how a medium influences the speed of light passing through it. It is obviously the optical density. Those who made a mistake in this question, it's okay. Anyways, optical density we'll discuss in detail, but do remember it is the measure that shows how a medium influences the speed of light passing through it. As optical density of a medium increases, the speed of light increases. Guys, if it's true, nod your head like this. If it's false, nod your head like this. True or false? When the optical density increases, speed of light decreases or increases? False or true? Those who didn't nod your head, what are your stands, guys? Those who are not nodding their heads. Dhruv, Dilip, what do you think? Not true, not false. Why not nod your head? Nod your head if it's true. Nod your head like this if it's false. Fine. So it is obviously false. As the optical density increases, the speed of light decreases. It doesn't increase. Fine. So before we wind up, any questions, queries, concerns? Fine. Run. Mugdha Sunil is like run. Yeah. In the previous question, you had an option, right? True, false, not true, or not false, and the last one was run. So how many of you clicked run? Just because it's the end of the exam time, right? So that's why I gave the option as the run. Don't run from the session. So before I wind up, no doubts, no queries? Fine. Everyone is like, sir, is a little bit tired today, so we'll ask doubts in the next session. No, you can ask me. No, right? No doubts, right? Fine. So thanks for tolerating me today. I hope everyone will revise. Everyone should revise the concepts of refractive index. That is important. Concept of refractive index, concept of rarer medium and denser medium. Very, very important. Got it? That's all for today. Thank you and have a nice day. Bye.